Welcome to the nth week of class. Today we're going to talk about hash tables. And I'm going to start out with, before we get into what if you were in charge of, you had to store the pick three lottery numbers for a month? Pick three. That means there's going to be three numbers. I don't know what they are. The numbers could be 652. Okay. The numbers could be 0, 0, 0, all the way up to 999. We'd like to use 0, 0, 0. We need the three digits there, but we want to store numbers, this choice of a whole lot of numbers. Okay. So I know when I store them, I may want to eventually go and say, hey, was the number 1, 2, 3 picked? And you need to store these somehow to see if that number 1, 2, 3 was picked. Okay, so I want to be able to, once I store these numbers, I want to search to see if it was picked. But my lucky number might be 1, 2, 3. And if I'm doing this for a month, that means I have 31 days. We're going to assume it's 31-day month. 31 days of numbers I have to store. I have to store 31 days of numbers. Um, what's really unique is if I'm playing this lottery, could my lucky number 1, 2, 3 be chosen more than once? Yeah. Yeah. So up to this point, I've done something as simple as said, well, hey now, you're a rock star. Get your cake. I might just I might try an array, right? And then the array, day number one, I put in the first number, 641. Day number two, 231. Day number three, and so on. I need an array of size 31 numbers. Okay. But here's my problem. I need this linear search to get through it, which means I have to go through the whole array and every time. When we start talking big O notation, this is going to be O sub n, and that's not a good scenario. Okay. That means I went through from beginning to end one at a time. But we also know there's other searching to search to see if I won. Again, my array size is good, but my searches stink. And again, what if it was 1,000 numbers? My other way of searching was a binary search. So I'm going to try putting this in an array, try the linear search. No, binary search. I need a better way to search and find a lot quicker. So what we're going to do is something called, well, wait a minute. What if I said, what if I created an array of size 1,000? Big array. Let's try this array. Try an array size 33 or 31 up here. Now I'm going to try an array of size 1,000. And boom, my number 123 was picked. So I'm going to do this. This is a new way. I'm going to go here to 123 and say, hey, it was picked. Well, I'm excited. What can I do? These are all going to be zeros to start. These were all zeros to start. And then when my number got picked, I turned this into a one so that if I ask the user, hey, What number do you want to see if it's a winner? Well, I'd like to know, is 121, 123 a winner? Bam. I searched my list. Yes, it's a one. That means it was a winner. Was 000 a winner? I search my list. Boom, I get his. No, it wasn't a winner. Okay. Yeah, I still have this little caveat listed up here. Could win more than once. Maybe I'd be changing this to a two so that I know 123. Yeah. So yeah, this first one was just, I had bad searches. Didn't use a lot of memory, but I had bad searches. This second one, I have a good search, but man, if I'm only using 31 days, 31 out of I'm using, oh boy, I'm using 31 out of 1,000 spots. How much wasted memory do I have? 960. I'm wasting 97% of these or more because it could be multiple. I'm wasting a lot of space. So I need to find a way that I get a happy medium where I don't use a lot of memory, but I also can search quicker. Problem posed. Now the solution. Yada, 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 yada. You're all excited. The answer is we're going to use a hash table. Okay. Oh, by the way, if this linear search was O sub n, what did this linear search become? It said I had to go through all n elements. This gave me a number calculated by doing my whole base two, and I keep cutting it in half and cutting it in half. So if there was 1,024 numbers, this would be 2 to the what power is 1,024? This would be 10. This would have been 1,024. This would be 10. What would this be? Anybody know? This guy is going to search and find it right away. That's going to be big O sub 1. And if you're not that far yet with the project, um, coming back to this, maybe that this will help later on down the road. Excuse me. So we want to be able to create a hash table. We want to store 31 numbers, and we need to figure out a way to store it. So the first thing we're going to do is create a something called a hash function, which is going to tell me a way to store where to start. Come on, here we go. My apologies. A hash function used to find a location to store the number I want. To store slash retrieve the number I want. What's that mean? Well, what if I said I don't want to use 1,000, but I also don't want to use 31? So I need to find a place to put it. Well, first thing I'm going to do is say, let's create an array size. And then I'm going to show you what's going to happen from there. All right, so I got this whole kind of idea going, and I'm going to say, I want to create an array size of. Well, let's see, there are 31 numbers I want to store. I'm going to create, and these are all different numbers, right? And so I want to create a way to store those, but I don't want to have a lot of wasted memory, but I don't want to spend all my time searching. So what I'm going to do is create an array that is of size, create array size of 1.5 to 2 times the number of elements. Okay. Oh, I keep getting all turned. 1.5 to 2 times the number of elements. Okay, so I have 31 numbers I want to store. So 31 times 1.5, 31 times 2, that's 62. This is going to be about 46. And so I'm going to pick a number in this range. I need a number in this range. And the number that I'm going to pick, I want to be a nice number that, yeah, that is a prime number. So give me a prime between 46 and 62. Are there any? What prime numbers are between 46 and 62? You got one? Shout it out for the world. Come on. Class interaction. Here we go. I feel it. Nicodemus, I think your lips moved, but you're muted.
47.
47. Is that the only one?
I think there are more, but
61.
61? Is 59 a prime between these two? Yeah, I think 59 works. Okay, here's what we're going to do. We're going to create an array of size 59. Okay, I like my number. We're going to go 59. So now I'm thinking if I'm going to store, I'm just thinking generically right now, 31 numbers in array size 59, I'm kind of happy. I'm only going to waste 28 spaces, but I also don't have to check 1,000 numbers. I'm finding that happy medium. I'm going to store it. Well, okay. I'm good. Here we go. Let's see what we got. I now need some test data, some numbers. Welcome to the day's lucky lottery. Your first lucky lottery number is somebody. Give me some numbers.
7.
Huh? Go ahead.
7.
7. More numbers.
12.
Bigger numbers. 0, 1, 2. Your lucky numbers. Welcome day 3. The numbers are 4, 21. Welcome to day number 4. Your numbers are 6, 6, 6. Welcome today. Remember, we have 31 numbers that we're going to store. 31. Your lucky number today was all zeros. Your lucky number today was 999. Wow, I get what's going on with those numbers. Why he's picking those. Your lucky number was 59. Your lucky number was 60. Your lucky number was, you got the idea, 119. Okay. All right. Let's see what we got. We now want to be storing these. We want to be storing them in our array. So this array goes from 0 all the way out to 59. Goes from 0 all the way out to 59. Because remember, I'm only storing 31 numbers and I'm going to store the actual number Where do you think we should put the number 7? Well, I have, actually, this is 58. My apologies. That's 58. I have 59 places to store. Where would be a good place to store 7 and say, hey, by the way, 7 was a winner. Can I go check to see if it's a winner? Damn, I found it quickly. I kept my big O notation down. Where would be that place to store it? Where would be a good place to store 7? It rhymes with Evan. I was just talking, I couldn't hear you.
Even?
We stored in 7.
Oh,
Let's go to location 7, and we're going to store 7. Yay, 7's a winner. The next one, 12. Where would we like to store 12? It rhymes with elf.
In
Rhymes
location
with
12.
12. Thank you. We can go to location 12 and store 12. Thanks. So far, so good. Now I can ask you, hey, by the way, did I wonder what we should put in here to start? What should they contain maybe to start? Pick a -1 number. All right. -1. -1. I'm going to fill the array with -1s to start. So I can go in and say, yeah, I can post. Where am I going to put 421? It's not going to fit, is it? So now I need to put 421 somewhere. So now what I'm going to do is create a hash function. And the simplest hash function is to do a modulus by the array size. And this is where it became important to pick a number that was a prime. Because when I do this, I'm going to get a unique. So if I do for this function modulus 59, I'm going to get a remainder of 0 to 58. Whatever that remainder is where I'm going to store the number. So if my next number is 421 modulus 59, that's going to tell me where I store 421. And by using this hash function, it'll allow me to store, but it'll also allow me to go retrieve. Where would you like me to put 421? Modulus 8. So this turns out to be 8. That equals 8. So I'm going to go right here to 8, and I'm going to store the number 421. Quick formula to tell me where to store it. Excuse me. Quick function to tell me where to go find it. Nice. My next number was 666. 666. Apply my hash function. What do you get? Where would we like to stick that?
17.
17. Awesome. That's going to put me out here at location 17. And I'm starting to say, I kind of like what's going on here. Quick storage, quick retrieval, not going to waste a lot of memory. My next number, 0. blah, 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 blah. I come over and say, okay, good. 0 is empty. Change that -1 to 0. Yeah, we needed to put something in there, so that's pretty good. We're going to put that in there. My next number, who's picking these numbers? 999. You ought to be in pictures. I'm going to mod it by 59.
55.
Here,
Um,
55. Du- 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 du. Glad you guys are good at this part. So I'm going to come out here. There's 58. I'm going to go to location 55. I'm going to store the number 999. Nice. My next, we're just 7, 12, 4, 21, 0, 9. Next number is 59. Where would I store 59?
element 58
Uh,
or no, wait,
if I do 59 mod 59 gives me what number? I believe that gives me a 0, doesn't it? And when I come over here, there's something there. How do I know there's something there? Because this
because
is
it's not
not
-1.
-1. So now I have this guy caused a collision. Caused the collision. And I have to figure out a strategy to handle collisions. Well, the simplest strategy of how to handle a collision. Handle a collision. Handle a collision. And the way I'm going to do it is I'm going to do probing. And in this probing. And in this case, the probing I'm going to use is called linear, which means, okay, I am going to go and say, hey, not problem. I'm going to do some probing and I landed on 0 and it's full. Where might be a good place to see if there's an open spot? Yeah, to 1. And since at 1, if I'm looking here right now at 1, before I get there, there's a -1 sitting there. So I'm going to land on 0 and I'm going to go, okay, it's full, but I'm going to go over here and I'm going to put it in there. So in this position, I'm now going to put the latest number, which was 59. Of probing. We like linear, and we're just going to do sequential. We're going to start and go to the right one, to the right one, to the right one. Other types of probing, I could go and go 1 to the right. No, I could maybe then go 1 to the left. That's full. 2 to the right, 2 to the left. So I have a bunch of different ways I could do probing that would get me to the next location. Another method is to go 1, this is the squares, then try, that's full, then go 4, then go 9. The different ways that I could remember how I'm moving to jump around to find a spot so that when I do my searching, I can get there quickly. So I had a collision. I needed to figure out how to handle that collision. And the way I did it was something called probing. Hey, so far so good. My next number was 60. 60 is going to have to go here in location 2 because I tried to land on 59. And yeah, that was full. So I went over to 2 and that's good. And finally, I can put 119 in my list. 119. 119 would go to spot.
Go to position 3 because it gives me only
Actually
your
go to
one.
3. It would actually go to 3. 119. Okay, so that's kind of all empty. That's all empty. Yeah. Okay, so we got, as doing this by hand, you're going to get a little cluster mess, but we got, okay. Now, if I want to go find something, great. I just use my function and check probing. So if I'm searching, my next thing would be to search. I would use that hash function to get to a location. Uh, if -1, blah blah blah, not found, it doesn't exist. If it's not equal, if it's not equal, that means I need to start my probe sequence. And I would follow that probe sequence to the right, to the right, to the right, until, if not a probe sequence, until found or a -1. Cool. If I land there and it's a -1, it's not found. Right? And if it's found, great. If it's not found, I do my probe sequence until it's found or -1. I'm starting to look at code of a while loop, some sort, to find it or not find it. Great. Questions? Happy so far? Well, every time I learn about a new topic, like a hash function, I come up with my inserts. Yeah, okay. First of all, I come up with my not empty function. Then I have my insert function. And then I would have my oh yeah, delete. And then I'm wondering about a traverse. As always, we have traverse. We could print out what we have all the way across. But this brings up a question of not empty. Is it empty? Is it full? Yada, yada, yada. Keep track. Insert. We just looked at how to insert. Traverse. That would be traverse slash search because we're searching for a number. Traverse might be more if we're just printing. Delete. And cool. I'm going to say let's do a couple deletes on our list. So down here, oh boy, what do we want to delete? We want to delete, let's see, I'm going to make up some numbers. We want to delete 700. We want to delete 59. We want to delete 999. We want to delete 60. All right, so I made a list of some numbers down here. 70, 59, excuse me, 700, 59, 999, and 60. Back up to my list. I come into my list and I say, hey, list, I am now going to delete the number 700. All right, 700, where are you? 700, where are you? I need my function. I need my function. 700 mod 59. What does that equal? 590, 110,
51.
51. Chingy, 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 chingy. I go up to 51. And what is at location 51?
-1.
The -1. Good. Check. It's gone. It's out of my list. 59. I want to go and delete 59. I come in my list because 59 mod 59 is 0. I go to 0 and oh, can I say it's not there? No, you can't. Okay, because this isn't -1. I knew this wasn't here because of the -1. So now I have to start my probing. And I'm going to probe until either I find 59 or I find what?
-1.
-1. And all of a sudden I found 59 and I'm deleting it from the list. Woohoo! Oh, what do I need to put in there? What should I put in there now?
-1.
-1. Okay. -1. 9.99. I come in and go, hey, cool, got it. I'm deleting you. -1, right? You're gone. Mod 59. We found it. It's going 60. What is 60 mod 59? What's that give me?
Wouldn't that give you 1 in the element position?
So I go and I check at 1 and it's not here and I have a -1, which means what? Oh crap. Because 60 is in my list. I see it there. But I turned this into a -1 and now I lose the concept of, hey, you better do a linear probe. Uh-oh. How do we solve this?
An
How do
idea
we
would be to
solve
have
this?
a intermediary integer that you add to the list saying that there was something here before you deleted it, and then when you uh, delete everything you want, then you update it.
Excellent. Good idea. I'm going to put that in dumb terms. We had -1 means it was empty from the start. But what if there was something there and I want to keep the thought process going? What number might I put in instead of -1?
You could do
About
-2.
Yeah, how about -2? So when I got rid of 700 and we did the mod 59, where was 700 at? Was that out here at 55? Yeah, I think so. So out here, we're now going to say, wait a minute, this is -2. It's empty and available to be inserted now. But if you're going to do probing, don't stop here. 59, we did that, and that was here. At 1, we're going to say, hey, by the way, this is available to store, but if you're probing, don't give up yet. 999, no, 700 wasn't anywhere. 999 was up here at 555. 60, I come in and land on 1 and say, oh, this is empty, but there was something here, so you might want to probe. If you need to fill it, fill it. But otherwise, I need to do that and turn. Yeah, now when I go and delete 60, I'm going to also make that a -2. So I put in a temporary value that says I'm available, but there was something here because you may need to probe away. Ooh, cool. Wow. Hash tables. Big deal. I got some notes. Want to make sure we cover them all. I hit everything up to this point. Ways to improve performance. So maybe depending on what change my table capacity. We used 59, was working pretty good, but maybe you want to go with a prime number higher. Could always add a little bit more. Use a different strategy for collisions. we talked about linear probing. There's all kind of probing that could have been done. What did I mention? Different probe sequences. Yeah. Use a different hash function. Well, we kind of like what we're using. All right. Here is the talk about 1.5, 2 times the number for the capacity. Okay. How to handle collisions. Linear is good, but can cause something called clustering. We started to see some clustering here at the beginning. These were all starting to stack up, but that's because the numbers that we picked were for a reason. We talked about a linear probe. Here's a quadratic probe. Add squares. Jump left, jump right, jump left, jump right. Another way would be a second hash function. Hash it and then hash it again. Okay? You're going to see reasons to change it, like letters. You work with the alphabet and you're storing different things. Um, that's coming down the road. All right, questions. Should we make up a scenario where you build it and do some deleting and on and on? Yeah, no? You pick, I'll pick. All right. We want to store, we want to store, let's see, 10 numbers. The numbers are between 1 and 100. And the 10 numbers are 87, 16, 25. Hang on, my nose itches. 15, 30, 31, 32, and 46. 1, 2, 3, 4, 5, 6, 7, 8. I need a couple more numbers. 52 and oh boy, 80. Store those in a hash table. First question you're going to answer. First question to answer.
The size?
Size. Okay. Anybody want to pick a size? Array size.
88.
No. No, 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 no. Whoa, that would be a huge array to only store 10 numbers. Okay. How do I pick my array size to store 10 numbers? Somewhere between 1.5 to 2 times the size. So we start with 10 and we want to go 1.5 to 2 times the size, which would be somewhere between 15 and 20. Give me a prime number between 15 and 20.
17?
17, yeah. Okay, create an array. Next thing I'm going to need is my function, and we're going to modulus this with the 17. 17. This is 0, 2. I don't know why I added one there. I didn't need to. Right now it's filled with negative ones. And I'm going to give you a couple of seconds to fill it up, Buttercup. Imagine it's 17, 87. I think this is going to go in location 2. Is that correct? 87 goes in location 2. Team goes in 15. 30 goes in 13. 31, of course, is going to go in 14. 32 is all the way over to 1. 46 is going to go in 11. 52 is going to go in 1. 80 goes in 12. Hey, wow, do I ever have a cluster? That's okay. It happens. Did I waste a lot of array space? No. Less than half is there's not much wasted. Considering it could have been 100 array spots, filling 10 with 90 spaces. Questions? Questions? That's a hash table. And again, you got the idea now. If I wanted to search for a number, if I was deleting a number, I'd have to change these to -2s. All right, I hope you got the concept. Hope you got the concept. All right, I need to stop saying all right already. We're gonna now take a look at what would we be doing, what I want you to start on in a group, which you're not gonna get a lot of time to work on, but I'm not gonna make it, I'd like you to keep working on it as a group, even if it's emails back and forth. But this was me trying to do another group project. When we were in the classroom, this works great. We walk in and I say, here we go, day 2. I want you get a leader and you go through and do this program. But I need to make sure I teach the concept, and for you to work on hashing is your program, and for you to work on this is your extra for experts. Well, not extra for experts. You need to know how to do it. But we're going to take a look at a program where all of this is about the group, where we're going to do this concept called chaining. This project, you will fill a data file with all the presidents' last and first names. Last name first. When you run the program, you will read the names in one at a time, store them using the chaining concept. You will need to use an array of linked lists, an array of linked lists to store the names. The names will be stored last name, first letter of the last names. All right. So if you write this program later, that's going to be great. But here's what we're talking about. Chaining. Chaining. We're going to have an array, and I'm going to make the array this way. Array sub 0 is going to hold a pointer. What's stored at array sub 0 is a pointer. What is stored at array sub 1 is a pointer. What is stored at array sub 25 is a pointer. Then this is chaining is a way to do faster storage and searching. Storage and searching. Now, this array is of size 25. Why is it of size 25? Because there are 25 letters of the alphabet. Any last name that starts with an A is going to come to here. We can take the ASCII value minus 95 or 92 or 65, whatever it is, get the number 0, which will put me to here, which will put me, oh, I kind of thought this is going to be based on Z. So the very first president would be George Washington. W would take me to a certain location, and I would store George Washington. Who was the second president? Good, Nicodemus. You said John Adams, right? Yeah. So the next, the first node that I created would be Washington George. And it would have a pointer to null. Wherever W is, W, X, Y, Z, which is like blah, 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 would now point to George Washington. Right now, these point to null. John Adams would now end up here. Adams, comma, John. No. Jefferson. Jefferson Thomas would be the next node. So you would go by that letter A, go to the array location where a pointer is stored to add to, and then you would go down the list and add it to the end. John Adams. Adams, comma, John Quincy, his son, would be on this list. So we would just keep chaining away and away and away and away. I get quickly to where I want to and go from there. Now, we're going to have a bunch of dead links in here, aren't we? Like there's no president that starts with the letter Z that I know of. Or Ulysses S. Grant. Yeah, there's a U. We have da 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 da. The concept of chaining are the questions. So what I'm going to do is let you get together and get started on this with chaining. This is available on D2L, so you can grab it and print it out. This is on the next test, so you would need to know how to do the chaining idea. But how you would get this up and started. You wouldn't even have to type any code today. You could just start typing an algorithm, how you would attack this, how you would do little blocks of code, how would you insert, how would you. So that's what I want you to work on. I'd love to see someone finish this. I think I actually have it for a 10-point grade. So let's do that. Your groups of three, your groups, here we go. To share. You are in, where are we at here? You are in, why your name's not on here? Oh, there they are. Group 1 is Nat, Joseph, Tilak, and Emily. Group 2. I think I have a deadline on this of Wednesday. When I open up breakout rooms, I want group 1 to go to room 1, group 2 to go to room 2. This is now officially assigned, and it's right here. It's worth 10 points, and I want to make sure I get it, that it has the right due date. Points. I thought I had all of this set. I'll get it set so you have until, what's a good due date for this? Wednesday night? Hey, I'll make it Wednesday night. I'm going to stop sharing. I'm going to open up breakout rooms. You know who needs to go to room 1? Who needs to go to room 2? Okay. Recreate 2 rooms. Let participants choose room because you know where to go. And off you go. That was a full day. All right, all right, all right.
Professor, did you open up breakout rooms?
Yeah, do you know which group you're in?
I didn't get the prompt for it.
What? Let me go back to D2L. No, hang on. You should be able to join group 1. That's your group, right?
Yep. All
And
right, now I got it.
now you got it. Okay.